Hi there, I'm going to take 5 minutes to walk you through optimizing your largest contentful paint to pass core web vitals. I'm Shawn O'Neill, Vice President of Performance Consulting at Yottaa, and for the past 10 years, I've been helping large e-commerce brands optimize site speed and UX. So first, why bother? Let's just take a look at some data connecting LCP to business outcomes. This is our data here from Yottaa, and we can see that as LCP increases, conversion rate in green decreases and bounce rates increase. So looking at this 1.3 second range, conversion rate is maximized and bounce rate is minimized. This is real data from Yottaa's customers spread across the entire portfolio of brands. So it's undeniable that a faster website is going to lead to better business outcomes. Optimizing LCP first requires making two upstream optimizations and making sure that those milestones are performant. So if we want to render the largest contentful paint element right here in 2.5 seconds, that means that we have to have rendered something, the first contentful paint, much before that, which means to have started rendering anything, you need to get a response from the server, this time to first byte. Time to first byte is that time from when the user initiates a request for an asset or a page, and the server starts to deliver it. If that's happening in 2 seconds, then we're out of luck on trying to hit LCP under 2.5. So we're going to tackle these 3 milestones in order, getting a response from the server as quickly as we can, rendering immediately, and then showing the LCP element. Let's dig into getting a fast server response. Hi, I'm way over here in Vancouver, Canada. And if I'm connecting to a server in California, I get a pretty good experience. Unfortunately, for those on the other side of the Atlantic, not so much. It's not uncommon for websites to take over 2 seconds to deliver the initial response, that time to first byte. This makes the entire experience of browsing a site feel really sluggish. So the first thing we can do about that is use a CDN or content distribution network for edge delivery, pushing the content from the server as close to the users as we can around the world. Of course, there's some caveats to how effectively a site can leverage a CDN, depending on what that code on the server is doing. So speaking of what the code on the server is doing, let's make sure we make as few database calls as necessary. If someone's landing on your homepage or landing page, there's no need to look up their cart contents or their username. There are some things that are going to be unavoidable, but as more calls are made in the database to look up accounts and line items and products, as you can see here, the longer that's going to take to return to the user. Dynamic content served in your HTML also makes that impossible to cache that page in the CDN. So it's actually doing double damage to your site speed. The main takeaway here is going to be aim for static HTML responses from your server and augment them with dynamic data via subsequent API calls. So if you want to get the cart contents, use an API call. Don't embed it right into the HTML. So that outlines what we can do about TTFB and get a fast server response. How fast is fast enough? Google recommends 800 milliseconds as a helpful threshold. We have customers with under 100 milliseconds on their static pages and under 200 milliseconds site-wide, so the bar is pretty high. We can do a really good job here. So great, assuming we have a fast TTFB, what's next? Let's talk about rendering. The migration over the last decade to building everything with JavaScript has had heavy performance impacts. So we want to avoid client-side rendering when possible. Your server should respond with useful HTML, not a JavaScript application to download and run before your visitor sees anything useful. The web is built on HTML, so server-side generated static HTML is going to give the browser the response it can start rendering right away. Next up, we need to get out of the way of the critical rendering path. A simple web page often loads 100 files or more to build the page itself, including HTML, CSS, JavaScript, all your fonts, images, videos, tracking scripts, you get the idea. The way that these are loaded can completely prevent rendering while the browser downloads and executes these files. So watch out for this little red triangle in your waterfalls, as seen to the left. These requests are blocking rendering completely, and we want to avoid those. So that's a few tips to optimize the initial render. We want to start rendering ideally in under a second. Google says 1.8, but you'll definitely feel the difference. Customers clicking through from an ad and then bouncing after staring at a white screen for 5 seconds are also costing brands millions every day. So start rendering immediately as soon as you get an HTML response from the server, and people will be happier. So now let's get into the main course, actually optimizing the LCP. So consider that first of all, only a small slice of your page is visible in the viewport when the page initially loads. This means that the vast majority of the page is not visible unless the user scrolls down. So in this case, this is the above the fold content, but this is the size of this whole page. So Roughly 11% or so of this page is visible before scrolling, yet most sites tell the browser to load all of the code. Stoco only loads 421 of their 474 requests on this page. Could be a little tighter, but I appreciate the effort. In the absence of putting some smarts behind your asset sequencing strategy, the browser treats all these relatively equally and just tries to download everything and execute it until it can start to do layout and determine what actually needed to be above the fold and below the fold. So we're going to give it some help. The first strategy here in code sequencing is going to be prioritizing above the fold content and delaying or deferring below the fold. The browser doesn't know what files are needed to render this or your hero assets until it's downloaded, parsed, and executed them. So there's a lot of compute that goes into that, a lot of wasted effort that many of your users will never see until they scroll to things into view. Next up, it's easy for over half of the files on a site to be loaded from third parties, i.e. not your own code. Plugins, tracking pixels, embeds, flyouts, you get it, chat widgets, etc. A lot of bloat, and it isn't the main reason you built your page in the first place. HTTP Archive showed that in 2024, a typical page often has up to 100 third-party requests. So we're going to talk about how to deal with that. So in summary, try to avoid using someone else's code to render that most important element on the page. If it's a video, host it yourself. Don't use a YouTube embed, for instance. The key takeaway here is tell the browser which files are going to be critical to rendering that initial view and preload them in the head. This is a really helpful strategy. Alternatively, then we want to asynchronously load or defer or further delay below the fold and third-party assets. So to recap, rounding it all off, we want to get a fast response from the server, doing this with solid CDN and responding with static HTML with as little dynamic content as possible. We want to start rendering right away by avoiding client-side rendering, especially for your LCP assets. And then we don't want to clog up that initial critical rendering path because the browser can only do so much. And then finally, to start rendering quickly, we're going to prioritize the first-party code above the fold and then defer or delay any third-party below the fold content. This starts to play into the LCP aspect as well. And so specifically for LCP, help the browser find that asset immediately and delay the rest, or lazy load the rest, for instance. Prefer native HTML over JavaScript plugins and embeds. Use the right file format, so WebP, WebM for movies and video files instead of JPEGs or GIFs. And then if you have a video element and it's going to be streamed in, you can use a poster attribute to preload that initial image and get a really quick LCP on your videos. So thanks again for watching. If you found this helpful, you can share it. Always love to connect. You can reach me on LinkedIn. And if your team could use some help or expert advice optimizing your web performance and core web vitals, please reach out, book a demo or a discussion with us here. Thank you.